So I thought today we'd do another What Is It video. This is a piece of gear I picked up at a local, again, electronics recycle place for a few dollars. It caught my eye just because it was interesting. There's a couple of switches, as you can see on the front. There's this BMC connector down here. And there's 5 7-segment displays. Looking at the opening for the displays, it's definitely hand cut. It's pretty rough, which led me to think this is probably some kind of hand-built piece of gear. Let me get her up here so we can spin her around, take a look at the back side. One of the things I did notice is, oh, sorry for how rough this is. If you look at where the power cord enters, there's actually a strain relief on it, which is nice and interesting. Bit of a professional touch there. The case is, to me, one of those cases that says 1970s or 80s on it. You know, it caught my eye, and for a few dollars, I thought, what the heck? So open this guy up, see if we can figure out what it is. So I've gone ahead and removed the screws. Got the top look, or the top open. Let's go ahead and take a look inside. Oh, interesting. It's a printed circuit board inside. I was assuming something maybe a little rougher in construction. Transformer in the back. Looks like diode bridge here. One of the diodes is different from the others. A couple of filter capacitors. A crystal. Trimmer cap, I'm assuming for setting crystal frequency for tweaking it in. Oh, something here labeled logic probe. That's interesting. And TTL logic. Interesting. I wonder what this thing is. Take a look at some of the chips. LS90 with a 14th week of 77 date code. I believe a 90 is a counter. 7490, 7490, 7490. Another 7490. I'm already leaning towards perhaps some kind of a frequency counter. 7400s. 1970, 37th week of 76 date code. Flip-flop. More 74 LS90s. Quite interesting. And a row of 9374s. 1, 2, 3, 4, 5. There are 5 7-segment displays. Those are obviously the display drivers. Interesting. The BNC connector here on the front seems to come into an analog stage here of some sort. There is a chip there. I don't recognize the part number on it. Fairchild, 22nd week 77. Don't know what the part number is. There was obviously a bodge here. If I can get in here with the other hand, not block your view, to this tantalum cap, and one leg on the tantalum cap is just floating there. I don't really see where the other leg was connected to. There's definitely a bodge back here. One of the leads on that transistor is floating in the air here over to a resistor. I've got a socketed chip there, which is a 7414. It's interesting, it's just sitting in some kind of socket. Rather interesting. Well, I'm leaning towards frequency counter. Oh, there's a logo back here I missed. Get this wire out of the way. Solid State Technology FTK 0130 kit. So it was definitely a kit, just based on what I see on the board. You know, it looks like a pretty standard auto-routed board from the era. At least I'm guessing auto-routed. It may have been manually taped up, although the corners are very consistent. The 90-degree angles down here and the repeating patterns. It has been tin plated, which is nice. I've got a dog calling me in the background. An 11C90. I don't know. It's interesting. The couple of wires coming through those holes are interesting. I'm tempted at this point to power it up and see if we can get a hint what it might do. Well, based on the internal inspection I did, it looks to me like it's probably safe to apply power to. It's not fused. I'm going to go ahead and slide everything back here, get everything in frame. I'm going to go ahead and do what I normally do, and that's just very gently tap the plug into the outlet enough to make contact, but not enough to get it in there under tension. I want to be able to remove it easily. Nothing. I'm guessing just on layout. This switch down here is a power switch. We'll find out. I will just do a gentle tap again. Okay, definitely. It's powered up. It's got leading zero suppression, it looks like. A decimal point. A switch that seems to do nothing. Wonder what it is. Well, I'm going to feed it in a square wave and we'll see what we get. So I've got the function generator turned on, set to 1 kilohertz. It's set to output a square wave. I've got the amplitude right now at 1 volt peak to peak. I'm hoping that's not going to be too much. Seeing that there was a bit of an analog front end on this, I'd hate to blow the front end in playing. Let's come back down and power it up. That was an interesting display. Let's look at that again. 8-9H. Wonder if it's just random garbage on the display drivers when it powers up. I'm going to reach up here and I'm going to enable the output. And it's enabled. Oh. No, that's correct. Oh, we actually saw it set. Well, I do believe it's some kind of a frequency counter. Go back to frequency here. 1 kilohertz. Let's bring it up to 5. Come back down. 5 kilohertz. It's definitely a small frequency counter. I'm going to bring the frequency up 10 kilohertz. Let's come up to 50. Well, spot on. 50 and 50, although these are relatively low frequencies. I'm going to bring it up to 95 kilohertz. I shot over a bit, a little bit of error there. 95. 96. I'm wondering if it'll react faster with this little switch in the other direction. Oh, that's setting a range. Okay, that makes more sense. 96, 97, 99, 100. I'm guessing it'll overrange. Oh, overranged? It's telling us it's overranged? It's an interesting little device. So I'm at 100 kilohertz. That's obviously 100 kilohertz. Looks to me like this thing will go to 99 megahertz most likely, which will be more than I can output. I'm going to change the function gen over to sine wave. This function gen will only go to 5 megahertz on the square wave. The sine wave will get me to 20 megahertz. Let's come back up here and let's do a 5 megahertz sine wave. 5 megahertz. Let's try 50 megahertz. Oh, my bad. The function gen only goes to 20 megahertz. Of course, I do that every time. So, this is just a cute little frequency counter of some time. I'm set to 10 megahertz. Tad bit of error, no surprise. 9 megahertz, 8, 7, 6. So let's go to, I don't know, 12.345 megahertz. That should be 12.345. Huh. Interesting little device. Well, I guess this will be a rather short video. Just did some Googling against the part number on the printed circuit board, the FTK 0130 or 0130. Absolutely no hits. Did a couple Google searches on the solid state technology. That's a rough one because there's a billion hits out there. I found nothing really led me to what this is. A couple other details. The crystal in it is 10 megahertz. Based on what I'm seeing, it's well in sync with my little function generator. So, it's been tweaked in good enough for what it is. Interesting design. Saying those couple of bodges in there are interesting. The tantalum cap with the floating lead. Kind of odd. I don't really see any kind of solder or anything that would make me think it was a bodge that was removed. I'm going to go ahead and set the unit back down flush. There is a hole there next to that tantalum cap that lead may have been meant to go down through. There's solder flux on it, but looking at the lead on the tantalum cap, the floating one there, I don't see any indication of solder on it. It's a somewhat tidy build until you get back here to this rather nasty little kludge. It's a couple bits of electrical tape underneath that floating socket with literally there's 5 volts in ground, and I think the 7414 is it a Schmidt trigger inverter? Not sure. I'd have to Google, so that might make sense. Take some of the noise off the edges in there. As it counts, the wiring on the switches is rather rough. It's got a home assembled feel to it. Though it's hard to say. It looks to me like the printed circuit board probably has plated through holes. We get up here to where, component side, there's what looks like a via that passes through the other side of the board, perhaps. Perhaps not. It's got to be. When I look at the sockets here, there's traces on the board coming out on the top side of the board from under the socket. So yeah, it must have plated through holes. I built a couple of simple kits in the mid-70s. I've actually got a couple of them here. We'll do a teardown on one of them. Kind of similar. Similar construction, similar generic case. Oh, I guess I have yet another frequency counter that will sit on a shelf. Well, sorry this wasn't more exciting. I'll catch you next time.